Hello and good morning to all of you. I welcome you to this video lecture on Big Data Analytics. In today's lecture, we are going to discuss about Big Data and its 7 V's. We will be differentiating structured and unstructured data, and we'll be discussing how a Hadoop cluster works. So let's begin today's lecture. Big data can also be defined through its 7 V's. And these 7 V's are volume, variety, veracity, value, visualization, variability, and velocity. I'll discuss each one of these 7 V's with you now. Now, this volume defines how much data we have. Like whatever we used to measure in gigabytes is now measured in zettabytes or even yottabytes. The zettabytes and the yottabytes I've already discussed with you people. The Internet of Things or IoT, it creates exponential growth in data, and projections show the volume of data changing significantly in the coming years. Second is velocity. See, volume is one thing, that huge volume of data is being generated, but it is being generated at a great pace. The speed at which data is processed and becomes accessible is termed as the velocity. So today, if the delivery of data is not real time, it is not fast enough. It is not considered fast enough. Then third V is the variety. Now, variety describes one of the biggest challenges of big data. The insights may come without structure. We have tweets, we have images, we have selfies, we have scans. The total asset may include many data types from XML to video to SMS. Now, organizing this data in a meaningful way is not a simple task when the data itself is changing rapidly. The fourth V is the variability. Now, variability is different from variety. For example, a coffee shop may offer 6 different blends of coffee. But if you get the same blend every day and it tastes different every day, that is variability. The same is true of data. If the meaning constantly changes, it can significantly impact your data homogenization. The fifth V is the veracity. By veracity, we mean truthfulness of data. Okay, so it ensures that data is accurate, is true, and which requires processing to keep the insufficient data from accumulating in your systems. See, a lot of data is being generated in today's world, but like most of the time, majority of the data is fake. So veracity, this attribute ensures that the organizations, they receive only the true data, the actual data. The next 6 V is the visualization. Visualization is critical in today's world. Like we can use charts and graphs to visualize large amounts of complex data, and it is a much more effective way in conveying meaning rather than speaking or discussing about data. We can also use spreadsheets and reports and other formulas. Then the last and the most important attribute is the value attribute. See, if the data is being generated at a huge pace, huge volumes of data is being generated, but if it is of no value to the organization, then it is useless. So the seventh V tells us that the value of data is also very important. So together these 7 V's sum up the big data and its meaning. Next, let's discuss about structured and unstructured data, the differentiation between the structured and unstructured data. See, till the year 2000 or around, relational databases, they solved the problem of data processing. But with the advent of Facebook, LinkedIn, Twitter, WhatsApp, came the concept of unstructured data. So while we were using these relational databases, we had a structure first and the analytics or the processing came later on. But unstructured data, it posed a greater threat of processing because it doesn't have any structure, right? So let's have a differentiation between the two. Structured data, like we have already worked with it in our relational databases, like it tells us what a table looks like, what are the rows and columns in the table, what is the format for storage, and obviously it is much easier to handle. But when we talk of unstructured data, it is like it's audio files, it's video files, images, chats, scans, graphs. So it is very difficult to store and analyze. So the problems with unstructured data are, number one, it has got no structure. Number two, the size is huge. And third, it is growing at a very, very fast pace. Let's discuss about now the big data and Hadoop concepts. So small question for all of you. Have you ever tried opening a 0.5 GB file for processing on your computer system? And if so, then what are the problems that are encountered? See, the first problem would be that it would take approximately 5 to 10 minutes to open up, and further time would be there for processing of that file since the file is very big. See, this I am talking about a 0.5 GB file. Now consider big data, like the minimum size for the big data file would be around 1 TB. So just consider the amount of time and the processing capability that would be required to process such a huge file. So to do some analytics on such files, we have Hadoop technology, which would first of all give us a distributed file system for storing the file. And number two, it would give us an analytics algorithm to perform some analytics on the file. Next, we discuss limitations of the existing solution, that is of the RDBMS or of the data warehousing. Now, what are these limitations? Let's have a quick look. There is a fixed schema of RDBMS. And the cost factor is also there because all these softwares, they've got a commercial aspect. You need to take some license to use these RDBMS softwares. And these RDBMS softwares, it works only on a sample or a portion of the entire data set. It does not, usually analyze the entire data sets. And the most important thing, it is very difficult to save and access huge files easily. We cannot save huge files. Consider a 1 TB file. If you have a 1 TB hard disk on your system, how can you store a 1 TB file on it? So storing of files is the first challenge that we have. And then we cannot perform analytics on unstructured data because when we were using RDBMS, we were first creating tables, we were fixing the structure, what a table looks like. Now, to perform analytics on unstructured data, the RDBMS is not capable of doing that. Okay, so what does Hadoop do? Like we are discussing about Apache Hadoop, what it does is that it helps us to store the huge files using the HDFS component, and it helps us to analyze these files using either the Apache Pig or Apache Hive or other utilities are also there in the Hadoop ecosystem. Let's now discuss the important part of a Hadoop cluster. Now, a Hadoop cluster is like a master-slave architecture. In a cluster, we have a heavy-duty machine known as the admin node, and further, there might be 15 to 20 commodity machines known as data nodes. Now, this 15-20 commodity machines I'm talking of since I'm considering a small cluster. Okay, actual clusters, commercial clusters, they employ thousands of commodity machines. Now let's discuss what this commodity machine means. See, a commodity machine means a machine which is prone to failure. That is why we employ such huge number of machines in the cluster so that if one machine goes out of order, the other machine can take its place. Now, let's differentiate these two, the admin node and the commodity machines or the data nodes. The admin machine is usually a Xeon processor with at least 64 to 128 GB RAM, and this commodity machine, all we say that it is prone to failure, but it is also a high-end machine. It uses usually an Intel i7 processor with a 2 to 4 TB hard disk and minimum 16 GB RAM. Now, while we are running a cluster, two daemons or two processes, they run on the admin machine, the admin node. First process is known as the name node, and the second process is known as the resource manager. Okay, this name node stores and manages and helps in accessing huge files. So name node is maintaining the metadata about data, right? Data about data it is maintaining. So name node is not actually storing the files. It is just seeing that which part of which file is stored on which node. The details we'll discuss in my subsequent lectures with you. But right now you can imagine that the admin machine runs two daemons on it. One is name node and one is resource manager. Okay, and this resource manager manages the analytics part of your data, right? And it is based on the MapReduce algorithm implementation. Now, talking of the data node or the commodity machine, it runs two daemons on it. One is the data node daemon or the data node process, and another one is a node manager process. So this data node, it interacts with the name node, okay, and it stores the actual data. So the actual data in the cluster is stored on the data node, and its metadata is maintained by the name node. Okay. Similarly, the node manager executes the MapReduce algorithm, that is the processing of the data, and it continuously interacts with the resource manager to do so. So this is how a cluster looks like. There are thousands of machines and they are arranged in cabinets like a drawers of a table which can be pulled out. Okay. And about daemons, we can talk that daemons are a type of program which run on Linux or Unix operating system. So when we are talking of Linux or Unix, we call it daemons. And when we talk of Windows, we call it services. So the daemons in Linux are the equivalent of services in Windows. So this is an introduction about Hadoop cluster. And in my subsequent videos with you, we would be actually creating such cluster on our laptops and would be seeing the behavior like how we can store the files and how we can analyze the data stored in those files. So this is all for today's video, and I'll discuss more on Hadoop cluster, its installation, and about the Hadoop ecosystem in my upcoming videos with you. Thank you so much.